EDX Core Pure, Sequences in Series 1, Summing Series. The standard formula for the sum to n terms of r squared and r cubed. The standard formula for the sum of n terms of r squared is given as sigma r squared equals n times n plus 1 times 2n plus 1 over 6. There are several different proofs of this result, and you will see notes and examples on the integrals site and in your textbook. You will be able to prove this result using mathematical induction in the next section. So here we're going to find the sum of terms called r squared starting at 1 and finishing at r equals 20. So quoting our formula, we know that n here is 20, so using our formula it will be 20 times 20 plus 1 times twice 20 plus 1 all over 6. So that's 20 times 21 times 41 over 6. And if we had to do that without a calculator, we could do a nice bit of cancelling. We could cancel a 3 there to leave 7, and the other 2 there to leave 10, which will give us an answer of 2,870. As we can see there, there's the working for that problem. There's also a standard formula for the sum of n terms for r cubed. It can be shown that the sum of r cubed terms from r equals 1 to n is actually the square of the sum of r terms starting at r equals 1 up to n. And there's a GeoGebra link there if you want to investigate that further. Hence, it follows that the sum of r cubed from r equals 1 to n must be, therefore be n squared, n plus 1 squared over 4. So that's our sigma r formula squared. For proof of this formula, you can look at your notes or look at the examples in integral and in a standard textbook. Also, you'll be able to prove this using mathematical induction in the next section of videos. So, for example, here we want the sum of r cubed terms starting at r equals 1 and finishing at 10. So again, n equals 10, that's the 10th term that we're going up to. So if n equals 10, we go straight to our formula, 10 squared times 10 plus 1 squared all over 2 squared. So that's 100 times 11 squared, 121 over 4, which is 3,025. And again, you can check your work in there in that full example. In the next session, we'll be looking at the standard formulae and how we can combine them for different summations.